Hello everyone, welcome back to in my YouTube channel, and today we are going to start the lecture number 4, which is a lecture series of electric vehicle course. And in today's session we are going to learn the complete battery pack designing and the performance, range estimation, and most important thing, the battery cooling systems. So friends, let's start. And before that, if you are new at my channel, please don't forget to subscribe and like the video. Okay, let's start it. So in today's session we are going to understand the fundamentals of design consideration. So what will be the design consideration? Like, we are going to cover the electrical part, and uh, we are going to for the mechanical, how battery packs are designed mechanically. Means there is a lot of loads are acting on a battery system when vehicle is in moving. So mechanical and thermal is most important, because when current is flowing through the circuit, it produces the temperature, it produces the heat. So in order to maintain the required optimal temperature, we should have a proper knowledge of this thermal behavior of the battery, and the life of battery, durability, performance, safety, and I'm adding one more, cooling of battery pack. Cooling of battery pack. So friends, if you will watch this video till the end, definitely you will understand all these parameters. Okay. So in our first slide, we are going to cover what is exactly battery pack. So battery pack basically designed on the basis of electrical design, in which what we will do deals with the contractor, connectors, uh, bus bar, series and parallel connection, junctions, placements, etc. And here in thermal management, what we are going to do, we deals with the heat generated due to the unexpected driving. Suppose if you are operating your electric vehicle, your EV in traffic, so what will happen? You will accelerate and deaccelerate. So during this operation, sometimes rate of current flow through the circuit will be very less, and sometimes it is very high due to the demand, due to the load on the motor. So the heat generation process will be high. So in this sort, battery, the life of the battery is to entire intended life. And the important thing is what behind to understand all these thermal management, so that we can place a better cooling system. If we will understand the behavior of battery pack, what amount of maximum heat it can generate in any condition, so accordingly, as per the conditions, we can go for the we can select for the cooling system. And in mechanical design, usually what we want to do, suppose if we have I am taking one certain geometry. Suppose this one is a small battery pack. Okay, so what we will do, what here mechanically means, what when the load will active on these plates, side plates of the battery, uh, how it will resist. So how strong you are, we are going to build this side plate of the battery first thing. Even we are not going to do the mechanical calculation here for the mechanical, especially since this is based on the complete electrical part. So we will not do the detailed process up, but definitely I will explain how we are going to do it. And in battery management system, this is very much important. How all these three, especially how these tools are going to management with the help of this, controlling the battery and communication status of battery, and it's most important. This is the when current is drawn from the battery, especially towards the motor, so that managed by the BMS. If charge is coming towards the battery, that is managed by the BMS. Suppose this one is the battery pack. So if charge is coming towards here, toward this battery, so that BMS is there. So that will charge will enters into the battery through the VMS. And if charge is leaving from the battery, so BMS is there. Charge will leave this battery with the help of BMS. So BMS is very much important. That means that can maintain the thermal management, electrical management, okay, and the communication process between the driver to the vehicle with the help of controller. So BMS is, we can say that it is a small controller for the battery, and which is the controller of electric vehicle. There are a lot of controllers are actually using an EV. If I am considering a master controller, so that is for the basically purpose of communication system between the electronic systems, and of course driver also. So let us move ahead in the next slide. What we are going to do actually. So design consideration of battery packs in electrical. What we are going to do, determine the capacity, okay, voltage and current, okay, and high voltage isolation. In case of high voltage, how we are going to isolate this system, isolate these cells from each other. High voltage, a short circuit scenario, and the efficient power deliver. How we will make sure for the maximum power deliver from the battery. And in thermal management, of course, the battery cooling system, most important. Even if you are working, a cooling system is kind of valve for the heart. If battery pack is the heart of the cooling system. So this BMS and cooling system is nothing, it's valves of the heart. You cannot avoid it. That's why the learning of this, because there is no such video on internet where you can find out how all these things are working. And improve pack efficiency and mitigate the thermal accidents, increase cell or pack life. If we are going to operate our battery with these conditions, means if we have a better battery pack cooling system, if we can improve the pack efficiency, if we can mitigate the thermal accidents, if we can increase the battery pack or cell life, so definitely that can be done with the help of thermal management system. That is what battery thermal management called BTMS, battery thermal management system. And in mechanical, we should ensure the structure, this battery pack is what? We should ensure this battery pack is completely safe if the certain amount of external load is going to act here. So that should be our primary concern. If the certain amount of load is acting here, so in that case, the battery pack is safe. We should also take care of what should be the cost, productivity and reliability of the battery pack, ease of assemble and the service, because the servicing and maintenance part is very much important for the battery purpose. So we should have a better quality of design, so easily it can be assembled and serviced if required. Aesthetic and compact and lightweight. We cannot design a battery, even the cost of battery pack is around between 35 to 40% of the EV. So we cannot design it like it put the similar weight of in the same ratio, like 30% weight of the weight. Even the battery pack is, the weight of battery pack is high. We will calculate today itself, we will calculate what should be the weight of battery pack. So the aesthetic part, how it is looking, even we are not keeping it outside of the vehicle, it is inside of the vehicle body. And compact is compact because the space is very less. Where we are placing the battery? We are placing the battery somewhere here. You can see we are placing the battery somewhere here. So there is not very much space. Other transmission and some more things unit we need to place here. So compactness of design is very much important. And of course, weight is a very much important factor for designing this battery pack. And what BMS design is doing, maintain the cell pack operation, means we are going to add the charging and discharging process, okay. And this one more important thing, that is what the cell balancing. Today we are going with these three, and this fourth is a fifth lecture of this lecture series, where we will do the detailing of the how BMS is going to be designed and what is the fundamental works and control and diagnosis of thermal system and event. And the important part is what? Communication. So this one is what the BMS here showing, it's smart. Okay. So here battery pack configuration overview. cell configuration, we can make the battery cells in a series. In previous session I explained how exactly you are going to uh, uh, keep the battery cells in a series, and how it is be placed in a parallel. So when we are making in parallel connection, that means here is cell plus minus plus minus plus minus, 1 plus and 1 minus, plus minus plus minus kind of. So this is what we are connecting it into the series, and here we can increase the voltage, and in series here we are connecting either plus plus and plus, either minus minus and minus. In this way we are going to increase the current of the battery, means capacity of the battery pack. So and this one is what the combination of series and parallels. And the structure, we have the case of the battery pack, cover of the battery pack, end plates. End plate means, suppose this one is the battery pack, I am saying the outer structure, so you are looking from the tops. So one plate will be here, plates of the one plate will be this side, other plate will be this side here inside, and one plate will be here this side. So packs of the battery pack and tie rods, cell holder, where we are going to, like suppose this circular plate is there to hold this cells, to hold this cell. Okay, where we are placing it, I would like to show you. We have, so what is exactly the cell holders and all. See, this here you can see. So these are the cell holders. Okay, so in real, actually in EV batteries, so these cell holders and spacing between these are very much important. And how we are going to make it, you can purchase the individual cell holders, either we can go for this as per the requirement of battery, but because it is very small, so plastic is okay for here. And in other case we are using the some different material also for the better stability, and even plastic is the best option because this is using for the insulation purpose also. And here you can see there is a gap between these also. Gap is very much important for the cooling system as well as for the purpose of cooling system, and also for the insulation purpose also. So this thing is what important for us in every aspect. And bus bar, fuses, wiring and plugs, and cooling jackets, safety valve and transmissions. And in a safety purpose we are going for the vibration shock, how it is responding, how battery pack is responding for the shocks and vibration. We need to understand this. Short circuits, overcharge and over discharge, how this going to be prevent. And thermal runway and thermal management, when it is completely discharged or full overcharged, not only in terms of current only, but also in terms of heat also. What happening when we are operating our electric vehicle at zero temperature, and what is going on when we are operating at a very high temperature. Even the optimal value for the operating EV is what, 15 to, not 15, I will say 25 degrees centigrade to 35, or you can make it 20 degrees. Sometimes 15 is also okay, but below that the performance of vehicle will be impacted. Cell monitoring and BMS, and here is what, temperature control and the communication. Okay, so we are going to learn each and everything apart from the mechanical calculations and all. And if you will say, definitely I will make a different video related to complete mechanical design, means casing, covering and all the thing, because we are focusing on electrical part. That's why I'm skipping that. What are the components of battery pack? We should know, if we are going to model this battery pack, we should know about the what are the complete upper housing. You can see here the upper housing, that is the covering part, and that is bus bar and copper bar. Here you can see, and connectors, wiring harness, cells, and the cell adapter module. Cell housing means for the covering of the cell, insulation pads between the cells, and cooling jackets, that is for the air or water cooled. Okay, And here you can see the transmitter, sorry, thermistor or voltage store, and underbody housing, battery management system, that means what, a BMS. The cooling jacket, battery cooling jackets are there, underbody cover is there, and you can see here the cell module. These are the fundamentals part of the our battery system. Cell is not there because we are going to fit the cells between these. Okay, so these are the parts of the components of the battery pack. And here you can see clearly about this battery. The diagram is more clear because cells is also there. Here you can see this one is what, the cells are there, and thermistor, voltage sensor is there, and here thermal means this one is what, a device for the making of temperature sense, for the temperature sensing. And this is what the voltage sensor is. Insulation pad is there. This yellow color is what, the insulation pad that is inserted between the cells. And this is base plate, which is for the supporting purpose of the load of the entire cell. That is important. And the cold plate here, that is what, bottom side here, and outer casing. This is what, where we are putting the battery inside that cell packet. And bus bar is there. The design of this bus bar is very much important and crucial, I am telling you. And this one is what, bus bar holder, and side side strips are there, wire harnesses are there here. At this place you can see end plates are there for the supporting the sideways of the battery pack. And this one is what, the BMS module, which is controlling all electrical plus mechanical plus communication part of the vehicle, communication of battery with the others. Okay, let us move ahead. One by one we are going to do what are the important consideration in battery pack. So material selection, how we are going to select the material, base plate design for each cell accommodation, cell movement constraint and control, uniform pressure over the cell surface, outer case design for the overall protection, and the bus bar designing, vehicle level packaging consideration and constraint. These are the factors, these are the points you need to consider during the battery pack designing. And friends, don't forget to contact on this given number if you are looking for complete study material, some PDFs, some my handwritten papers, and some PPTs, videos, material, study material, and for the certification. If you are looking for learning after 3 months, 3-month certification or 6-month certification, don't forget to message on the given contact number. And here how we are going to do the cell packaging. One important thing you should note here, the details you should note here, okay, because we are going to do the manual calculation. I will do along with you. If you have a copy and pen, then you should start from here only. So here we can say this red part is showing the positive terminal, we are making it as red, and here it is negative terminal pack. Okay, don't confuse. This battery is or slightly rectangular, this one you can see. So the height of the battery will be the maximum, whatever it is, and breadth of the battery will be slightly higher than the length. So don't confuse, always length will be higher than the breadth, that given here. So the nominal voltage of this battery of this cell is what, 3.65 volt we will consider, okay. And the current is what, current of one cell is what, 15 amps, that we will consider. Length is what, 17 mm, breadth is what, 65.4 mm, and the height of this cell is what, 125.8 mm. This is the standard, okay. And here you can see in this battery, we are connecting the positive and negative, means 1 2 3 4 5 6 7 8 cells in parallel, okay. 8 means what, आपको you will see the pack something like this. Here it is looking 8p1s. That means what? 8 cells are in parallel and 1 cell is in series. This is stand for series. Okay, and 8 cells are in, this one is what? This one is in 8 cells in parallel. So parallel and series you need to understand. For this is what? One cell is what? 1 1 1 1 1 1, it is in series, and this one 8 is what? Parallel connected here. Okay, this is what? The plus 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 point connected there. Okay, and here you can see when it is 8 cells are connected. Let's see here, when we have 8 cells are connected in parallel, so 8 number of cells connected in parallel. So let us calculate, make it small here, I am making it. And if 8 cells, we know when cells are connected in parallel, 8 cells in parallel means 8 cell multiplied by the capacity of 1 cell. So that will be what? 120 Ah. We are getting here 120 Ah. Okay, I hope you can understand this. And the second in what? This is what? 120 Ah is what? The capacity of battery. What is it? Capacity. And now what will be the power? Power means P is equal to voltage into current. Okay, so here you can calculate power also. So power will be, voltage is what? 3.65 multiplied by 120. Okay, so what you are getting? Just multiply this. I have already did it. So I am getting 0.438 kilowatt hour. And in what? Obviously it is 120 into 3.65, that will be 438 watt hour, and this is 0.438 kilowatt hour. So this is what the calculation for the series. And let us parallel. And when you are looking calculate the same thing in parallel, so 8 cells are in series, 8 cells in series. So that means what? 8 cells into multiplied by, now we will multiply with the voltage. Here we have multiplied with the current. Okay, and here we are multiplying with the voltage. So we will get 29.2 volt. That will be the total voltage when one cell is connected in series. 8 cells in connected in series. And the voltage battery pack, this is what the voltage of battery pack. And the power here, power of battery pack will be, already we know about 0.38, but you can calculate like this one, 15 Ah, that is current of one cell into 29.2 volt is the watt. That also you will get the same thing, 438 kilowatt hour. Here I have calculated, just I manual calculation and did for the proper understanding. Let's move ahead. Next portion. Let us consider one example. Why I taken this? So that you can understand when you are going to do this calculation part, you should know about what exactly the things are going on. Okay, so let's take one example. Consider a vehicle is designed to have range of 200 kilometers. Okay, which consume 25 watt hour kilometer. Please note this value. So 25 watt hour per kilometer is what? The an average from a battery pack to run. Consider DOT. DOT is depth of discharge is 80%. Nominal operating voltage of battery pack will be what? 96 volt. And power consumed by the auxiliary systems are 5 watt hour per kilometer. Means that power is consumed by the systems of the EV itself, that we are not using into work. Okay friends, let's do it. So here what is given? The range is given as 200 kilometer. We will do this calculation manually. Okay, I have not calculated before. I want to do it with you. So range is what? 200 kilometer is already given. Consume, how much power it consumes? Sorry, it consumes 25 watt hour per kilometer. Okay, and DOD is what? Depth of discharge is 80%. That means what? Depth of discharge means we will discharge this battery up to 80%. Okay, 80% discharge means 20% remaining. Like SOC is what? SOC is saying health of charge, sorry, state of charge. This is state of charge. That means suppose this one is a battery and here charge. This is 80% charge. So if it is showing 80% here, so that means the state of charge is what? 80%. And depth of discharge is what here? 20% is DOD. With the help of one example you can understand. And 80% is what? SOC. Okay, I hope I made this clear for you all. So let us move ahead. So now we need to calculate the power. Required power calculation. So required power is what? 20 watt hour, first thing. So that is for per kilometer, 1 kilometer. So what will be for 200 kilometer? So for 200 kilometer, it is simple to understand. That means 200 multiplied by, this is what? 25 what? It is consuming, and plus 5 watt hour, it is what? Auxiliary system is consuming. So 25 plus this multiplied by 200. So we are getting 6000 watt hour, and we can write it 6 kilowatt. So this power we are getting from power requirement for the 200 kilometer. Got it or not? Now considering DOD is what? 80%. DOD is 80%. So that means 6 kilowatt divided by 80% means 0.8 we can write. So we are getting it 7.5 kilowatt hour, or you can write 7500 watt hour. Most important thing, DOD is 80%. Suppose this 60% is there, we will divide by, if I am writing, if DOD is 60%, so what we will write? 6 by 0.6. Okay, so we will get a different answer. Got it or not? So that's why how you will need to do. Okay, and if it is 50%, divide by 0.5 means 1 by 2, that will be the 12 kilowatt hour. Okay, I hope I made it clear for you. Now in a single page I want to do, I think it is visible, still it is visible for you. Now I am drawing this line, I am writing here in this side. So voltage requirement from motor is what? Voltage requirement So here I already mentioned this is 96 volt. Okay, so 96 volt we will write here, it is a 96 volt. Okay, so current requirement, current required, okay, of battery pack, that will be 7500 and divided by 96, because this is what? Depth of discharge. So 96. So what we will get? We are getting 78.125. Okay, that is what? The current required, I required. Note it along with me. And if 15 Ah battery used, so number of parallel connection required, because this is total current required, right? 78.125 volt is required for the 200 km range, and given all the details whatever it is. So how much cells required cells in parallel? Focus here friends. So because the current is what, 78.125, so I am writing here, if 15Ah battery used, so number of parallel cell connected. So how much parallel cell will be connected if this one is what? So what we will do, simply we will divide 78.125 divided by 15. Okay, means that is total current, and this is a cell of one, current of one cell. So we are getting 5.20. So I'm consider 5 parallel cells. Note down now, whatever the battery pack you are going to design with these specification as per given in the questions, so you required 5 cells in parallel. How much it is parallel? 5. Now we are going to calculate how much cells will be present in series. So that is also very much important to know how many cells will be there for present in series. Okay, let's move for the other. I hope otherwise you can just take a screenshot. Okay, I am holding here. Okay, done, fine. Let's move ahead. Otherwise I can do one thing, we can add one page here for the calculation, or I am minimizing it, no problem at all. Okay, so let's move ahead. So because we have 3.65 volt, है ना, battery used, how much it is? Battery used, that means one cell voltage is what, 3.65 volt, है ना. So we will write number of series connection. Number of series connections is equal to what? 96 divided by 3.65. Got it or not? Total voltage what we are looking? 96, and one cell voltage is what? 3.65. So if we are dividing it, we will get 26.30. I am considering 26 series cells. Okay, got it? So how battery pack, we will mention the battery pack. Now we got the answer. We have 5 parallel cells and 26 series cells. So how we can write the pack name? We can write 5P26S. This is what the pack. Battery pack is what? 5P26S. I am telling you again, first of all, total voltage required we have 96 volt. Okay, 80% is what? The DOD. DOD is what? 80%. So because the total consumed power we have what? 7.5 kilowatt or 7500 watt. So we have divided this, because the DOD is what? 80%. So we just divide with the help of 80% or 0.8. So we got the value of what? 75 kilowatt. Got it or not? Initially it was 6 kilowatt for the consumed power. So 7.5 kilowatt or 7500 watt is whatever is what? The power. So voltage required is what? V is equal to what? P upon the power is what? DOD. DOD we got 7500. So we divided with the help of what? Current required. I is equal to P by P is equal to VI. So I is equal to what? P by V. So voltage is what? 96 and power is what? 7500 divided by 96. See, we got total current. I is equal to 78 point something. Okay. So that is what the first thing. When total current we got, so because since one cell current is what? 15 Ah. If total is that one, so we will connect the parallel, and if voltage of one cell 3.65 volt from here use, so total series connection, because 96 total voltage, one cell volt, 26 will be in series, and 5 will be in parallel from here. I hope it is up to this part it is clear for you. Now, so number of cells in battery pack, how much cells will be there? Number of cells in battery pack. Now you can tell me, in a battery pack, how many cells will be there in a battery pack? So we will have 26 in series and 5 in parallel. So total we will have 130 cells. That means for this battery pack you required 130 cells. Okay. So in 130 cells, so number of rows you can go for the, how much number of rows is there? If you want number of rows and column, I'm 130 cells is there. So rows, number of rows 5 parallel, and cells in row 26. Okay, because this is what we have. So as per the space in vehicle, like you can design the pack like this, 5 in this side, 1 2 3 4 5, and 1 2 3 4 5 up to 26 is this side. This should be the battery pack. Otherwise what you can do, if you don't have this much space, so you can just cut it half like this, and you can add here. So your battery pack will be like this, 13 will be this side and 13 will be this side. You can paste it here, or you, as per your space and convenient, you can make it. Got it everyone? Very nice. Now let's calculate the what will be the dimension of your battery. Dimensions of your battery. See how we will calculate. So breadth of the battery pack, how? Breadth of the battery pack, how we are going to connect? So see, I am telling you, take this one as a one cell. Okay, if it is not like that, we have something like this, something like this. Okay, we are something like this. So length is here, width is from here to here, and height is from here to here. So we will, if we want to one more, what we are looking, suppose we are looking to one more, so we will paste like this, 2 cells are there. If we are looking one more, 3 are there. We are looking one more, 4 are there. We are looking one more. So this is what we have, terminals positive and negative. So don't confuse, what will be the breadth of the cell? So we have 5 in parallel, so we will multiply it with 5 in parallel and into the 65.4. so this value give the breadth, and already you know the length of cell is what? Length of cell is what? Breadth. What will be the number? You can just calculate and get. If I will multiply 5 into 4, 20. This is something 327 mm, right? And if we are looking for the length of the battery pack, will be, so there will be the 13 cells or 26 cells. So we will simply do it what, 26 into length is what, length is very less, battery pack the length is what, very less, 17 mm. So we will multiply this, you will get the length of this, and length means this one, this one, this one, this one, this one, this one, this is the length, and that size is what, the breadth, and this one is height, and height will be absolutely, that is 125, which is already given, that is height of cell, mm. And this is what the pack of this. Apart from that, here you need to use what, you are going to use the case, most important thing. Okay, now you have used the case, you need to cover it here, got it or not, you need to cover it here. That means base plate you are going to use, plates are going to use here, and here also you are going to use the covering plates. Then bus bar and many more thing apart from this, and then you are going to use this for the connection purpose, wiring, harness. So this is what the minimum space. After then the covering, casing, other things you need to do. So I have given you the details of the cell package modeling. Okay, I hope you understand this part. Let's move ahead. Battery pack thermal calculation, how we are going to do it. Okay, let us consider one thing here. Consider a battery pack of 2p, means 2 cells are in parallel and 16 cells are in series, whose specific and nominal capacity is given 15 Ah. You need to remember it. Nominal voltage is what, 3.65 volt, you should remember. Internal resistance 10 milliohm, you should remember. If the module is discharged from 100 to 20%, means 80% it is going to discharge. Associate 1 coulomb, means 1 hour. Time is what, time is given 1 hour. Calculate the heat generated, energy expelled by the module. Also compare the energy lost as the total module of it during the discharge. So we need to calculate how much energy or heat will generated with the help of one cell or with the help of total battery pack. How much heat one cell will generate and how much heat will be generated by the battery pack. Now the comparison between that. So very small calculation is there. See, I am not going to consider the material properties and all. That will make the calculation is very much complex. So to avoid the complexity, I'm avoiding the many things like material property, coefficient of thermal constant, thermal coefficient, and many more things I am avoiding here. Okay, I'm excluding. So during the real calculation, you can just include that. So heat generated in each cell. Current is what? 15 Ah. Cell resistance is what? 10. So heat generation की IR into T you can consider, because I am considering T is equal to 1 hour. So that will be the multiplied by 1 only. So that you will find 2.25 watt hour. That is the cell generator. The heat is what? Q is equal to, or H is equal to, we are writing I square RT. I square RT. This is the formula. And here time is what? 1 hour. From 80 to 100 to 20%, it is taking 1 hour. एक बैटरी है जो कि चार्ज है पूरा, कितना? 100% it is charged, and from 100 to 20% it is taking 1 hour time. Okay, that is what the mean of SOC at 1 coulomb. Okay, 1 C. So H is equal to, that is the same value you can put here. So now you have calculated, this is 0.2 this one. Okay, next one, heat generated by the battery pack. Total number of cells we have here and this here, 16 series means 32. We have 32 cells, heat generated by the complete pack. है ना? So Q cell, how much it is? Q cell, it is to this one and multiplied by the number of cells. अरे भाई एक सेल जितना जनरेट करता है, टोटल में क्या करेंगे, नंबर से मल्टीप्लाई कर देते हैं. दिस इज फॉर वन सेल, दिस इज फॉर n number of cells. One cell generated by this one, so total cells will generate by what, 32 cells are there, so 32 multiplied, that means 72 watt hour you can consider here. H also by mistake I didn't mention it. Okay, so energy lost by the battery pack, time for 20 to 20 SOC. See, this is what 1 hour means. 1 hour we have 3600 seconds. So how much it is discharging? 80%. So for 80% we are writing this 0.8. So time in 1 hour 36. So total we will take how much? We have 2880 second. One thing I'll make it clear. Suppose 100% battery is there and here 0% is there. So it is taking from here to here 1 hour. Okay, and we are discharging it from 20% only. We are not reaching here. So from 100% to 20%. So that is taking 1 hour is what, 3600 seconds. So how much time it is taking from here to here? So that is taking from here to here 2880 seconds. Got it or not? And if it is reaching from here to here, that will take additional some more seconds here, around 600-800 seconds. That will take more for 20%. Got it or not? So that is the concept about. So heat lost by cell, we will write Q into T. So 22.25 of one cell, and time is what, this one. So 6.48 kilowatt. You can calculate 6.48 kilojoule, sorry, was the heat lost by the cell, one cell. And battery pack, so I know there is a 32, so we will multiply 32 into heat loss by 1. So we are getting 207.36 kilojoule of energy. Got it or not? भाई पहले हमने 100 से 20 आने में कितना टाइम लगेगा निकाल लिया, वो कितना आया 28.80 सेकेंड. फिर उसके बाद हमने किया एक सेल कितना एनर्जी लॉस करेगा, इसी टाइम को हीट से मल्टीप्लाई कर देंगे तो एक सेल का एनर्जी निकल आया कितना लॉस कर रहा है. फिर टोटल बैटरी पैक सेल कितनी एनर्जी लॉस करेंगे, सो वी विल मल्टीप्लाइड बाय व्हाट इज द नंबर ऑफ सेल्स. सो इन आवर बैटरी पैक देयर आर 32 सेल्स, जो अभी नया एग्जांपल लिया, तो 30 सेल से इस एक वाले में मल्टीप्लाई कर दिया हमने, तो 32 मल्टीप्लाइड बाय 6.48, सो वी गॉट इट 20737 किलोवाट. Okay, kilojoule. And comparing the total energy pack energy, what 100 to this one SOC, what is equal to VIT, we understand it, power VIT, and N is what, the number of cells. So we have 32 multiplied by volt of one cell multiplied by capacity of one, tie is equal to 1. So total we are getting 5045.75 kilojoule. Okay, and if we consider compare the last, in this case we are getting 4.1% loss of energy. One calculation I just exclude, I know you understand how to find out the like a comparison. Okay, and let's move ahead. So we got it, how much heat is generating, total heat is this one. Okay, and this one is what, comparison heat. Move ahead. So battery pack assemble thermal now it is the most important part is coming. So best desired operating temperature is what, ensure the battery operation under optimal temperature range condition within reasonable temperature. Important. Monitor state of battery, detect critical point battery failure, deliver alarm messages, suppress thermal runaway propagation. See, this is what the temperature T, and here what you can see the temperature was 15 degrees centigrade, here the temperature is what, 35 degrees centigrade. So if the battery is operating between this 15 to 35, the desired operating temperature is, सपोज आपने एक ईवी लिया और अभी आप राजस्थान में थे, टेम्परेचर ऑब्वियसली 35 से बहुत ज़्यादा के टेम्परेचर में आप ऑपरेट कर रहे हैं, यहाँ पे ऑपरेट करेंगे डिग्रेडेशन शुरू हो जाएगा इसका बैटरी का. सो दैट विल इम्पैक्ट ऑन SOH, स्टेट ऑफ हेल्थ ऑफ द बैटरी. हेल्थ उसकी डाउन होना शुरू हो जाएगी अगर आप कंटिन्यूअसली इस टेम्परेचर पे इसको क्या करेंगे, क्रूज करते रहेंगे, चलते रहेंगे चलते रहेंगे चलते रहेंगे. एंड सपोज आपने वो गाड़ी लेके अभी आप कश्मीर पहुंच गए जहां पे टेम्परेचर आई नो इट इज लेस देन 15 डिग्री. नाउ यू आर ऑपरेटिंग ओनली, you are not operating in this range. In this range you are not operating, you are operating in this range and in this range. So that means life of your electric vehicle battery pack will be less. Got it or not? So it is important to the experiment shows that from here to here below this one, I will tell you what will be the impact of low temperature and high temperature on your battery pack. But you should know about at high temperature your battery performance will be decreased, and your low temperature your vehicle battery performance will be decreases. Okay, let's move ahead. How it will impact? The answer of your question is here. If the battery is too cold, what will happen? When Q is what? Less than 5 degrees centigrade. Temperature is what? Less than 5 degrees centigrade. So fast charging nahi hoga. Fast charging will not possible. Or rate of charging will be decreased. And if temperature is what? Greater than 0 degree centigrade, what will happen? If temperature is what? Less than 0 degree centigrade, something like. Here is what? Temperature is greater than 5 degree, and here is, we can set just is if temperature is greater than 0 degree centigrade. So battery will lose charge itself, loss power, acceleration, driving range in exponential rate. 5 degree centigrade तक तो सिर्फ you can get the serious problems you can observe, but below 0 degree centigrade that will be destroy the things, electrical things. I'm talking about the battery pack and what is happening when you are operating at if temperature is below 30 degree centigrade or just increase, just greater than 30. 30 is what? 30 is less temperature. If working temperature is increasing more than 30 degree centigrade or just above 30, battery performance degrades. Okay, and if it is operating more than 40 degree centigrade, so that can lead a serious problem. Even in summertime, the temperature in Rajasthan at some place, it is going to 55 degrees centigrade. So that temperature is essentially is very harmful for your electric vehicles. So if you are living in a kind of zone, make sure your vehicle should have a very proper cooling system. Forced air cooling is not sufficient for that. So to be aware customer is also important. Okay, I hope when you are going to purchase the electric vehicle, make sure at what temperature range your city is nearly, and the second point is what, which kind of cooling system your vehicle have. Air force cooling system is not sufficient. You will understand how it is. How battery is heating, already know कि how battery is heating is. अभी नो फास्टर बैटरी चार्जिंग रेट्स, हाउ बैटरी इज हीटिंग, है ना. बैटरी गर्म कैसे होती है? एक तो है कि करंट जितना ज़्यादा फ्लो होगा हीट उतनी ज़्यादा प्रोड्यूस होगी. एंड फास्टर बैटरी चार्जिंग रेट डिमांडेड if faster rate is greater than 200 kilowatt, so time is very less. In that case heat will be very high. In fast charging condition time is very much high. I hope you understand. Fast charging condition, so heat will be very high. And if you are accelerating or if you are climbing the hill, if you are driving on a mountain, so in that case also heat generation will be very high. And faster battery charging, you can local electrode evaporation, evapotential, and entropy of cell reaction, heat mixing. Some more reasons are there, but these three are very much important. So outside from how we are charging, battery cooling, how we are providing essential some charging systems which are I'm going to explain you. So how we are taking just outside air, and we are in the, suppose this is what the battery pack, this one, and outside air is coming from here, and that is entering into the battery pack and going outside. This is what the very first kind of cooling system. But if we are using air and coolant means whose temperature is very less in comparison to air. So what is happening, how we are taking this one? So outside air is coming into heat exchanger where the temperature of air is what, and one coolant is there, coolant is here. So temperature of air will decrease, that air will flow into the battery, here you can see, and from battery obviously the air will be heated, so that air through the pump again it is coming to exchanger. Got it or not? So heat exchanger is what here, to reduce the temperature of air with the help of coolant, and air is sending to battery pack, and battery pack is sending the air with the help of pump again into the hazer. That circulation part is continuously going on. So this is what quietly better method, and it is also the cost effective. I hope you got it. This one is very simple, and here you can see the medium of refrigerant. We are using the refrigerant for the battery pack. Suppose the air is and cooling system is from this side, this one is battery pack. So refrigerant is also helping for the maintaining temperature better. You understand the refrigerant temperature is very less, and if it is mixing with the air or a liquid, that will decrease the temperature of that one, so that will be helpful for our battery packs. But refrigerant is slightly costly, coolant for the air AC, and I hope you all know. So by air coolant, air and coolant, so this is the same like there. AC heat exchanger is there where temperature we will decrease the temperature of with the help of coolant, and heat exchanger, simple heat exchanger is there, and outside refrigerant is coming into outside air and refrigerant is coming here, and in this part we are decreasing the temperature, or we are mixing with the refrigerant, air is mixing with here and decrease the temperature. The second step we are making this more cool here, then this heat is transferring to the battery pack, and from battery pack heat air is here, you can write heat air and coolant. Heat air and coolant is coming here with the help of pan and coming out. So this process is, that is quite similar, but here we are using the coolant. Refrigerant is also kind of coolant. Now let us understand what are the battery pack references. Nissan Leaf is using air cooling, Nissan N20 200, Honda Inside, Honda Fit EV, Toyota Prius Prime, and Renault Joe, and Hyundai Ioniq. These are using the air cooling battery pack references with the help of refrigerant and coolant. Make sure. Okay. So up next we will understand how other companies are, how they are using the cooling system. What is the patented technology of the Tesla? That is what? This is Tesla patent cooling tubes are there. So here liquid cooling battery packs, who is using? Chevrolet, GM Chevrolet Volt, Tesla Model X, Model 5 and Model 3. So the costly vehicles are, because cooling system in EVs are very much, for the battery pack is very much costly. And Ford Focus, they are using Audi R8 e-tron, here is a Toyota iQ, Volvo X. The car, every car is more than 60 lakhs. I am talking in Indian price, Indian rupee. You can convert it into dollars, so you can see the prices of the electric vehicle cooling. So if you are working in a project, for a project of making a cooling system for the battery pack, that will be awesome, I think. And liquid cooling battery packs, here you can see the tubes are there, how it is circulating among this pack. there is not a very efficient kind of cooling system. The Tesla have one. Okay, the other companies do not have currently. They are working for making it better and better so that the SOS, the life of battery, we can increase. Refrigerant direct cooling system, we have BMW and we have Mercedes, Quatron Saga, Audi, BMW A6. This is what PHEV, and this was BMW X5, BMW i8. So BMW is working on the refrigerant. This is efficient and cost effective mostly. And here now you can understand what are this is the last slide, I think. So air cooling, liquid cooling and refrigerant cooling. Okay, so cooling, heating performance, cooling is very high, liquid cooling high. This is not up to, not for the heavy vehicles. And system complexity, this is very simple. Complicated, this is also compact structure. Complicated is always, when we will mention this one, this will be the high cost, and many more things are there. This is complex one, I will say. And cost, this is very cost, low cost, and this is high cost. This is potential lower cost, less than this one but higher than this one. And weight, light weighted, relative heavy. And this one we can write intermediate weight is there. Intermediate you can write here. Okay, and the safety, better in sealing and waterproofing, leakage concern in liquid cooling, and that can damage your battery pack also sometime. And safety advantages are there in refrigerant, because when refrigerant will out, that will be evaporate. The temperature are very less. Temperature spread, difficult to maintain even temperature, because we are doing this with the help of air only. Easy to maintain, we can maintain our battery pack temperature at required temperature. And better temperature in uniform description, control and limited and precise. And here controlling is, that is good. You can see controlling good. Okay, control is there. So up to this part, I hope you understand and you have learned many more things. Stay tuned, and please subscribe my channel, share it with your friend. And if you are looking for study material and certification, don't forget to contact on this given number. So मिलते हैं next video for the battery pack modeling and BMS. The next is what? Next is what? Next is BMS. Don't forget to attend it. Okay. So in tomorrow or day after tomorrow, you will get this video. And continuously I'm making the videos for skilling you in electric vehicle technology. Thank you so much. Thank you for your watching, and please don't forget to like and subscribe the channel. Jai Hind.